Okay, so female student only or final year student. Okay, so based on certain characteristic. Okay, so let's say there is some claims that that is we want to see estimation. Okay, what is the proportion for female students in your samples? Okay, all right. So you want to do some get the interval estimation with that. Okay. All right, so this is everything is only the formula is similar, okay, but we refer to the difference. We use a different symbols, okay. All right, so first you have to identify the sample proportion, okay. All right, or maybe sometimes in the exam it give provided to you, okay. Or if you do a research, okay, you do a data collection, then you have to calculate sample proportion here, okay. All right, so let's say based on the that students do, so you get you have 300 sample, okay. So then you calculate the female student. Maybe from that you get 120 female students. So the proportion of female students is 120 divided by 300. So it's about plus minus 40 plus lah percent, okay, 0.4. Okay, then you have to calculate using this formula, right? So then you have to identify the standard error of the proportion, okay. This is the formula to calculate the standard error of the proportion so that you can get a margin. Then after you times by the Z distribution, then you will get a margin of error, right? So this is the formula for standard error of the proportion. Right, so P bar, small p, okay, and small p, okay, is for sample proportion, okay, so sample proportion. So this is a symbol sigma with the hat here, we call it a hat, sigma hat, and P bar is a standard error of the proportion. Is sigma hat X bar is standard error of the mean, okay. Alright, so then to calculate the interval for proportion, okay, then you have to calculate upper control limit for proportion and lower control limit for proportion, okay. So this is confidence interval for a proportion for population, okay. So we using a data sample, we can identify the we estimate the interval for a population proportion, okay. Alright, so the formula to calculate the upper and lower control limit, P bar, okay, so you get from the previous formula or it's provided to you. Okay, so P bar plus minus Z value, Z distribution from the table, okay, from the table or that based from the certain value, okay. How you can refer to the table based on the confidence level, okay, and then times by standard error of the proportion, right? Okay, so this is the either you want to refer to the table or if you can remember this, especially for interval, then you don't have to wasting your time to refer to the table. Okay, so if the confidence level provided to you is 90%, so automatic, if you can remember this, okay, 90% confidence level equals to the value for Z score is 1.645. Okay. If the confidence level that you want to use is 95%, you 95% confidence about your data, okay, then the Z value is 1.96. Okay. If your confidence is 98%, okay, so the Z value is 2.33. Okay, so if your confidence is your confidence level about your data is 99%, so the Z value is 2.575. Okay, so if you can remember it, it can save your time. So you don't have to refer to the table. Okay. All right. Okay, so go directly to the example. Okay. Right. So the here from example here, from a random sample of US citizens, 22 out of 100 people are found to have blue eyes. Okay, so out of 100, 22 is found to have a blue eyes. Okay, now you calculate a 98% confidence interval for the population proportion of blue eyes US citizen. Okay, so in this case, they already take a sample about 100 people. Okay, so from that 100 to they identify that 22 have a blue eyes. Okay, so based on that, you want to calculate a 98% confidence interval. Okay, so first you have to calculate the sample proportion and the standard error of the proportion. Okay. Alright, so calculate 98 based on 98% confidence interval. Okay, so calculate sample proportion. For that one is a step by step. Okay, so sorry. So we will go step by step. Okay, so first you have to calculate the sample proportion and then calculate the standard error of the proportion. So how to calculate the sample proportion? Okay, so X divide by N. So 22 divide by 100. So this is a sample proportion. Okay, so you get the sample proportion. So from this sample proportion, then you can calculate the standard error of the proportion. Okay, using this formula. Okay, so P bar is 0.22. Okay, then you can calculate 0.22 times by 1 minus 0.22 and divide by N. Sample size is 100. And then square root. Okay, then you get the standard error of the mean is 0.041. And then to calculate the margin of error, so standard error of proportion, you have to calculate by Z value. So Z value based on 98%. So Z value for 98% is 2.33. Okay, so Z value for this is 2.33. And then you can calculate the upper control limit and lower control limit for interval for population proportion. Okay. Okay. So upper control limit P bar time, plus Z value times by standard error of the proportion. Okay. So 0.22 is P bar plus 2.33, which is you get from the 98%. Okay, based on 98%. Times by 0.041 is your standard error of the proportion. Okay. This is for upper control limit and then lower control limit. So you have to minus from the P bar. Okay. Alright, so then you can make a conclusion. Okay, so based on our sample proportion of 0.22, we are 98% confident that the population proportion is between 0.124 and 0.316 or 12.4% to 31.6%. Okay, that have a blue eyes. Okay, right. So based from your sample, okay, from your sample, you get 22 out of 100 means that about 22%. Your sample in your sample is 22% have a blue eyes. Okay, that you win. So if you want to use a point estimation, your point estimation is 22%. Okay. Right, so point estimation is directly you based from your sample, then you estimate directly to population. Okay, so using a point estimation is 22%. Okay, you estimate for population proportion. Okay, but using an interval punya estimation. Okay, so based on 98% confidence level, you found out that between 12.4% to 31.6% have a blue eyes. Okay, so that's a conclusion that you can make based on 98%, your 98% confidence level. Okay. All right. So any question about this proportion before we go to? I think after this is some exercise. Any question? How many here? Only 15. Okay. Where is another 10 student? Isra. Okay, so this is an example. So maybe you can try to do it yourself. I give you about 5 minutes or 5 to 10 minutes lah. Okay, to highlight the information and then try to get the standard error of the proportion and then construct the interval. Okay, based from what you understand, right? Okay, then we will discuss after this. Okay, anyone have the already complete answer the question? Okay, what is the P bar value? Sample proportion.
70? No.
Hmm? No.
No. I don't know.
70 is a sample of 70 retail. 70 is an N.
N. Oh yeah.
N. Okay, so P bar is 0.66. Okay. Performance of the retail industry 66% is automatically given to you, provided to you P bar. Okay. So 66% believe that decreased sales were due to unreasonably warm. Okay. And you want to construct that who blame warm weather for low sales. Okay. Right, so 66% believe that warm weather ni will affect a low sales. Okay, so 0.66. Okay, so be careful. Maybe the proportion that provide to you is the contrast value from what you want to estimate. So just be careful with the statement. Okay, so but in this case, it's the same proportion lah. Okay, so P bar is 0.66. So then how you can get the standard error of the proportion? Okay, so 0.66 times by 1 minus 0.66 divide by 70. Okay, so what is the standard error of the proportion? 0.057. Okay, so Z value based on 95% confidence interval. What is the Z value? 95% confidence interval. Okay, so 95% confidence interval, Z value is 1.96. Okay. 1.96. Okay. So now you can calculate you upper control limit and lower control limit. 0.66 plus 1.96 times by 0.057. 0.66 minus 1.96 times by 0.057. So what's the value for upper control limit?
For lower control limit is 0.54,
0.54. Upper?
and upper is 1 second.
Upper is 0.771.
Yes. 0.77.
0.771.
1.
Okay. Alright. So that is upper and control limit. So this is for B. Answer B, and this is A. Okay. A and B. Answer B. Right? Okay. So it's quite easy. Okay. So as long as you understand, you can identify which one is your N value and which one is your P value. Normally students will confuse with P bar and N value. Okay. Right? Okay. So we are 95 confidence that the population proportion is between 0.45 to 0.771. Okay, or we are 95 confidence that population proportion is between 54% to 77.1%. Okay, from the sample, if you want to use a point estimation. Okay, so the value for point estimation is 66%. Okay, directly. Okay, so we estimate when use a point estimation, directly we take a sample proportion, we estimate for population proportion. Okay, point estimation is 66%. Interval estimation using a 95% confidence, that is between 54% to 77.1%. That the executive believe that warm weather will affect low sales. Okay, right? So it's quite high lah. Okay, the proportion that believe warm weather will affect the will reduce the sales volume. Okay. All right.
Doctor, I have a question.
Okay.
Can you just briefly explain how did you get that 0.057? That how did you get that?
Am I calculate wrong?
No, I just want to know.
0.66. This is the formula. 0.66 times by 1 minus 0.66 divide by 70. Then you square root.
0.66 times 1 minus 0.66 divided by n. Oh, okay. All right. Yeah.
70. Did anyone get a different value? If you get different value, then just inform me. Don't worry. I also make a mistake. Okay, don't worry about that. Okay, just mention it if I make a mistake.
I just wanted to know the formula.
The formula. So 0.66 we should times by 1 minus 0.66. Okay.
Okay, thank you.
Okay, so you mean 0.57 here? Okay, it's from here, right? Okay, so we have another exercise. So this is the answer. Okay, so we have another exercise here, right? So please, you have to do exercise, then you can understand very well. Okay, that is how you learn a calculation. Okay, when you want to start to do a statistic, so first you have to identify the relevant information. So you have to identify what is the N, and then P bar based on what your characteristic that you want to calculate. Okay, and then Z value. Okay, so in this case, okay, we have 3 characteristics. Okay, we have 1000. And then we have 3 different response. Okay, so one response that yes, that children better off than their will be better than their parents. Okay, so 24% respond yes. Okay, and then about 530 adults respond no, okay, and then not sure, about 25% respond not sure whether children will be better than their parents or not. Okay, so question A is that what is the point estimate of the proportion of the population of adults who do think that the today's children will be better off than their parents? Okay, so the characteristic is based on adults who do think that today's children will be better off than their parents. Okay, so how many respond yes? How many adults that thinks today's children will be better?
470.
470. How you get 470?
Because 530 people saying
Response
no.
no. Oh,
Yes.
okay. So be careful. All right. So now you have 1,000 adults. Sorry. I want to use silent letter. Okay. So 1,000 adults. Okay. So a response of yes. Remember, you have 3 response here. Yes, no, and not sure. Okay. Even though 530 adults respond no, okay, thinks no, but for those who respond yes, it's only 24%. Okay, 530 respond no, and then you have another 25% respond not sure. Okay, so A want to estimate, point estimate proportion that adults who do think, okay, agree lah, okay. So how many answer yes?
240.
Yes, okay. So point estimation, sorry. P bar for A is 0.24, not 240, okay? Because it's a proportion. Proportion of the population. Okay, so proportion of the population. Okay, so proportion is in point form, 0.24. Okay, so that is a point estimation for those who do think that today's children will be better off than their parents. Okay, 0.24 directly. Okay, very simple. Okay, so what is the 95% confidence interval for the proportion of the population of adults who do think that today's children will be better? Okay, so this is for yes. Okay, so then you already have the proportion, population for yes. And the C is that what is the 95% confidence interval for the proportion of the population of adults who do not think that today's children will be better off than their parents. Okay, so the characteristic in a C is different from B. Okay, adults who do not think today's children, okay, who do not think. So how many answer no is 530. Okay, so then you have to use a proportion based on 530, not 0.24 anymore. Okay. Alright, so then you, okay, I give you a clue. Okay, I have you a little bit clue. Okay, so this P bar is different from the above one. Okay. All right. So to answer question B, P bar is 0.24. Z value. What is the Z value?
The Z value is 1.96.
Yes, 1.96. Okay. And then to calculate the interval is UCL 0.24. Oh, sorry. Before that, you have to calculate the standard error of the proportion.
It is 0.013.
13, 30. Or
13. 1 3.
13. All right.
But I'm not sure.
Anyone who get the same answer or different one? Okay, so I assume only they get the same answer. Okay, plus 1.96 times by 0.013. Lower control limit is 0.24 minus 1.96 times by 0.013. Okay, so what is the value for upper control limit and lower control limit?
The upper is 0.26.
26? 26? Exactly 26.
No, it's not clear. It's it has I erased it.
5. Isn't it?
Yeah. One yeah. Yeah.
Lower is
For 21 4 0.214. Yeah.
40. Okay. All right. So for the interval estimation, based on 95 confidence level is between 21.4% to 26.5%. Okay. So point estimation is 24%. Is the point estimation. Okay. All right. So C, different characteristic. Okay, so then you have to recalculate P bar. Okay, so P bar is those answer no is 530 divided by 1000. Okay, so 0.53. Standard error of the proportion is 0. Divided by 1000. Okay, so this is 0.53. Is 0.016. Okay. All right. So now you have to calculate. I bring it up here. Upper control limit and lower control limit based on 95% confidence. Okay. So Z value still maintain 1.96. So upper control limit is 0.53 plus 1.96 times by, please check whether my standard error of the proportion correct or not. 0.016. Okay. So lower control limit 0.53 minus 1.96 times by 0.016.
So for upper, it will be 0.561. Yes, for upper.
0.561.
Yeah.
Okay. Lower?
0.498.
498. Okay. So you have 90, based on 95 confidence level, level, the interval for population proportion is between 0.498 to 0.561. Okay. Or based on the 95% confidence level, I believe that between 49.8% to 56.1% of adults who do not think that today's children will be better off than their parents. Okay, so then you have to write the conclusion, or maybe because it's objective, then you have to choose the right conclusion. Okay, right, to represent your answer. Okay, so just to confirm with you that we will still proceed with our final exam, okay? Right, because the last, because we have to make sure that we have covered all the learning outcome, but our learning outcome for final exam that I specifically put in the final exam. So I cannot answer that when the TDA asks me that in which assessment that I cover that the last learning outcome. So I have to proceed with the final exam. Okay, if not, it's not simply that we can just cancel the final exam. Okay, so we have to make sure that learning outcome is complete everything. Okay, all right. So we still proceed with the final exam. Okay, but it's objective. Don't worry about that. Okay.
Oh, so it's not multiple choice question?
It's objective multiple choice. Okay, it's
Oh,
multiple choice or maybe true or false, or match the answer, have to match the answer. Okay, different, but you don't have to show the calculation. You calculate and then you just choose answer that represent your, based on your calculation too. Okay.
thank you. Yeah, thank you.
You have to make sure, because I try to make sure that which area that students might get confused or get the wrong figures, it's a probability that you will get the same. The answer is there, but it's actually you are wrong in your calculation. Based on your experience, okay, based on what previous experience, so this is the potential of student make a mistake. Okay, so I do the same. Okay, and you put the answer is in that choice too. Okay, so just be very careful, right? Okay.
Thank you.
Any question?
No.
Okay, so no question. Then I think we will continue on Monday with hypothesis testing. Okay. All right. So, but I hope that you try to understand about because hypothesis testing in chapter 6 is like a continuously from this estimation. So try to revisit and understand about this estimation, whether for proportion or estimation for mean. Okay. Right. Okay, that's all for today. I'll see you next week on Monday. Okay. So,
Thank you, Doctor.
Bye-bye, everyone.
Bye.
Thank you. Bye.
Bye.